Ever wondered how to graph a quadratic function that looks like this? Y equals x squared minus 4x minus 5? In this video, we'll go step by step through how to find the axis of symmetry, vertex, y-intercept, and how to plot points to sketch the curve. Let's get started. Example 1, y equals x squared minus 4x minus 5. Step 1, axis of symmetry. The standard form of a quadratic equation is y equals ax squared plus bx plus c. Here a equals 1, b equals negative 4, and c equals negative 5. To find the axis of symmetry, use the formula x equals negative b over 2a. Substitute b equals negative 4 and a equals 1. That gives x equals negative negative 4 divided by 2 times 1. Simplify to get x equals 2. So the axis of symmetry is the vertical line x equals 2. This line divides the parabola perfectly down the middle. Step 2, vertexing. Next, let's find the vertex. We already know the x value is 2. Now, plug in x equals 2 into the equation, y equals x squared minus 4x minus 5. That's 2 squared minus 4 times 2 minus 5. Simplify. 4 minus 8 minus 5 equals negative 9. So the vertex is at the point 2, negative 9. This point represents the lowest point on the graph since the parabola opens upward. Step 3. Y-intercept. To find the y-intercept, let x equal 0. Then y equals 0 squared minus 4 times 0 minus 5. That simplifies to y equals negative 5, so the y-intercept is at 0, negative 5. That's where the graph crosses the y-axis. Now let's find two more points close to the axis of symmetry. We'll start by letting x equal 1 and x equals 0. For x equals 0, we already found the y-intercept at 0, negative 5. Next, let's use x equals 1. Plug it into the equation, 1 squared minus 4 times 1 minus 5. That's 1 minus 4 minus 5, which equals negative 8. So one point is at 1, negative 8. Now we can sketch the graph. Start by drawing the axis of symmetry at x equals 2. Plot the vertex at 2, negative 9. Add the y-intercept at 0, negative 5, and the points 1, negative 8. The distance from the axis of symmetry to the point 1, negative 8 is 1 unit. Using symmetry, the next point will be 3, negative 8. We can do the same for the y-intercept at 0, negative 5. It is 2 units from the axis of symmetry, so the reflected point will be at 4, negative 5. Finally, connect all the points with a smooth U-shaped curve that opens upward. Now let's move on to our second example. Y equals negative x squared plus 6x minus 5. Here, a equals negative 1, b equals 6, and c equals negative 5. To find the axis of symmetry, use the formula x equals negative b over 2a. Substitute b equals 6 and a equals negative 1. That gives x equals negative 6 divided by 2 times negative 1. Simplify to get x equals 3. So the axis of symmetry is the vertical line x equals 3. This line divides the parabola right down the middle. Step 2, vertex x. Next, let's find the vertex. We already know the x value is 3. Now plug in x equals 3 into the equation y equals negative x squared plus 6x minus 5. That's negative 3 squared plus 6 times 3 minus 5. Simplify. Negative 9 plus 18 minus 5 equals 4. So the vertex is at the point 3, 4. Since a is negative, this parabola opens downward, making the vertex the highest point on the graph. To find the y-intercept, let x equal 0. Plug it into the equation, negative 0 squared plus 6 times 0 minus 5. That simplifies to y equals negative 5. So the y-intercept is at 0, negative 5. Now let's find two more points close to the axis of symmetry. Start by letting x equal 4 and x equal 5. When x equals 4, plug it into the equation, negative 4 squared plus 6 times 4 minus 5. That's negative 16 plus 24 minus 5, which equals 3. So one point is at 4, 3. Next, let x equal 5. Plug it in, negative 5 squared plus 6 times 5 minus 5. That's negative 25 plus 30 minus 5, which equals 0. So another point is at 5, 0. Now we can sketch the graph. Start by drawing the axis of symmetry at x equals 3. Plot the vertex at 3, 4. Next, add the points we found, 4, 3, and 5, 0. The point 4, 3 is 1 unit to the right of the axis of symmetry, so its matching point will be 1 unit to the left. That's 2, 3. The point 5, 0 is 2 units to the right of the axis, so the reflected point will be 2 units to the left. That's 1, 0. We also have the y-intercept at 0, negative 5. Using symmetry, reflect it across the axis of symmetry to get another point at 6, negative 5. Finally, connect all the points with a smooth U-shaped curve that opens downward. Notice how the two graphs are mirror opposites. In the first example, the parabola opens upward because a is positive. In the second example, it opens downward because a is negative. By finding the axis of symmetry, the vertex, the intercepts, and using symmetry to plot points, you can easily sketch any quadratic function. That's it for this lesson. Now you know exactly how to graph a quadratic step by step.